Hello everyone, welcome back, and today we are solving Leetcode problem number 756, pyramid transition matrix. I will first explain the intuition step by step and then we'll talk about the logic behind the solution. So we are given two things: bottom row of a pyramid, for example like B, C, D, and a list called allowed, which tells us which block can be placed on top of which two blocks. So our goal here is very simple. We have to check if we can build the pyramid all the way up to one single block. So if we can do that, we return true, and if not, we return false. So what does allowed mean? Each string is allowed has three characters. For example, BCC, which means B is on the bottom left block and C is on the bottom right block. The third character will always be placed on top of the first two blocks. So if we see B and C next to each other in the bottom row, we are allowed to put C above them. The order matters here because BC is very different from CB. So let us take an example here. Let's say our bottom row is BCD. So our allowed list contains BCC, CDE and CEA. So let's take it step by step. From B and C, we place C, and from C and D, we place E. So our new row is C and E. And from C and D, we can place A because in the allowed list, we have CEA. So now we are left just with A on the top row. So now we have reached the top, so the answer is true. So an important thing to notice here is we don't have to use every allowed block. We only need one valid path to the top. So why is this problem tricky? Why is it marked medium? Because sometimes we have multiple choices. For example, if the bottom is BCBC and allowed to contain BCA and BCD, then for BC we can place either A or D. So now the question becomes, which one should we choose? The answer is try both. This is where we use backtracking. So let us think like this. We try one option. If it works, great, we're done. If it fails later, we go back and try the different option. So it is basically like a maze. We keep track of every choice we make, and if the choice does not work out, we backtrack and see where the choice branches out to another choice, and we go and try that out. And we stop when we find that one solution that reaches the top. So why is brute force okay here? The constraints help us to understand this a lot. The bottom length is at most 6 and there are only 6 different characters. So the worst case is each pair can lead to 6 choices. So the total combination is 6 power 6, which is totally manageable. That is why backtracking works efficiently here. So the core idea behind the solution is we start from the given bottom row, build the next row character by character, and once full row is built, treat it as the new bottom. Repeat this process until we reach a single block and we return true, or all possibilities fail and we return false. So the best case is success. If the length of the current bottom row is 1, that means we've built the pyramid completely, so we return true. And base case failure optimization is we also keep a set called scene. If we ever reach a row that we've already tried before and failed, there is no point in trying again. So if the current row is already in scene, we immediately return false. This saves us a lot of time and avoids repeated work. And we use the data structure set to store the rows we've already explored and failed, but this works only in Python. So now that we have understood the intuition behind the logic, let us get coding. So first we are storing the length of the current bottom row. So this will be used again during recursion, and then the map stores which blocks can be placed on top of which pairs. We use default dictionary list, so we don't need to check if the key exists. So while building the map, each string is allowed exactly 3 characters. For example, BCA, A equals to B, B equals to C, and C equals to A. And then we map A and B as a pair, so it can produce a block C. If multiple rules exist, this method supports it. So this is why backtracking is needed. And then we initialize a memoization set. So this set basically remembers the rows we have already tried and failed. Why? So because if we reach the same row again, we already know it cannot reach the top, so we stop early. This avoids repeated work. And we define a backtracking function, This recursive function tries to build the pyramid starting from the bottom. So the parameters are bottom, row and I. The row partially builds the next row and the I is the current index. And in the next line, length of the current row is being processed, and if the row has only one block, we have reached the top of the pyramid. That is the definition of the base case that we are doing here. And if we finish building one row, that is if I is equal to n, all the adjacent pairs have been produced and now the row is complete, so we can move on to the next row. So if we've already seen the row and entered it in scene, we know it leads to failure, so we don't need to try again and we can return false. And if the row has not been entered in scene yet and it failed, we enter the row in scene and now it is marked as visited and failed. And next, the completed row becomes the new bottom and we start building the next level from scratch. That is why we return the bt as row and 1. And by initializing pair, we are forming a current pair by taking the two adjacent blocks. And after this for loop is initialized, we are doing for this pair, we try every possible block that can go to top. So if any pair succeeds, we immediately return true. So this is a very classic case of depth first search with backtracking. If all the options have failed, we then return false. So that's all for today. See you later. Bye bye.